Let's build a workflow editor that can be used in any application. Then we're going to build an image processing application on top of it as an example. You'll be able to use similar techniques to create video editing pipelines using FFmpeg, visual scripting, deployment pipelines, and much more. I've already created a very simple structure for the project. If you're on VS Code, just run npm install and press launch. Otherwise, you should run the scripts directly from the terminal. They are super simple. One of them runs esbuild to bundle the client's JavaScript and CSS and puts them in a directory called dist, short for distribution. The other one runs the server directly on Node.js. And notice that I'm using the experimental strip types, which allows us to run TypeScript on Node.js, which is absolutely lovely, and I've been waiting for this for years. And that's all the setup we need to get us started. The server sends a simple HTML for the homepage, which includes links to the JavaScript and CSS files. It also serves any requested file under the distribution directory where the bundled JS and CSS files are located. Alright, let's start with building the grid background. We want it to be a grid of small dots 50 pixels apart, which can actually be made entirely in CSS. First, we make a container for the editor, and also make sure that the page has no margin or padding because some browsers do by default, and also expand everything all the way down to fill the height, and also give a background color to the editor. Now to make the dots, first I'm going to disable the background repeat just for a moment to better see what's going on. To make the circle, start with a big radial gradient as background image. It shows a circle that starts at the center, is colored red until the radius reaches 50 pixels, it is fully black starting at 100 pixels, and it stays black for the rest of the background. And it's a gradient between the two colors. Let's remove this gradient to make the edges sharper. We do that by removing the gap between the two colors and leaving only 1 pixel difference. But the circle is not supposed to fill the whole container. Let's say it should be only 200 by 200 pixels, starting in the top left corner. Then we tell the browser to repeat the background in the x-axis as well as the y-axis, which is the default anyway, so remove it. Then we make the second color transparent instead of black, and that shows us whatever is behind it, which here is the background color. Now let's adjust the sizes and the colors and extract all these into CSS variables at the top so that we can have them all in one place, easily adjustable. Okay, that's a nice looking grid. Now let's show a node on top of that. We're going to start with writing the data structure describing what a node is. This is a pattern you're going to see over and over again. I almost always start with the data structure as the foundation and build a tower on top of that. So what is a node? What do we need to know about a node to be able to show it on the grid? Well, we need the x and y coordinates to know where to show it. We need a title to know what to write inside it. And we also need an ID so that we can refer to it and distinguish it from another node. And what is a workflow? Well, a workflow is just a bunch of nodes and edges. We could simply keep the nodes as an array, and that's perfectly fine. But we have to find nodes by their IDs all the time. So for easier access, we put the nodes in an object by their IDs. Let's create an example workflow with 2 nodes. Use it in a React state, and then map over the nodes to render each. In the node UI component, we put the title of the node as text inside the node, and to position the node correctly, we set the style in JavaScript based on the x and y coordinates of the node. In our CSS file, I'm going to add a color palette using CSS variables so that we can refer to the colors by their names. I'm also going to add the font and the color of the page, and finally write the CSS rules for the node. The most important part of it is to give it absolute positioning. Otherwise, the X and Y coordinates that we set on the node's style from JavaScript wouldn't apply. Because by default, the browser lays out the elements one after another in what is called the document flow. By giving an element an absolute position, we essentially remove it from the normal document flow and control its position manually. Okay, we have our two example nodes on the screen. Now let's see how we can drag them around. The browser already features a drag API, where we can set drag event handlers on any elements to be called at the start, during, and at the end of a drag. But that API has some bugs and some counterintuitive behaviors, so I usually stay away from it, except when I need to handle dragging something like a file from outside the web page. But to move a node right here on the same page, we can just use the mouse up, mouse down, and mouse move events, which are just so much easier to work with. We have two choices here for how we approach it. We could set different event handlers on each thing that can be interacted with. One set of handlers on the nodes, another set on the edges, and another one on the grid itself, and so on. You might call this a more modular design, but I prefer to have the entire mouse logic in a single place. This may not be as modular or as customizable from the outside, but it does give us a lot more control over exactly how the mouse events are handled. And that's why I set only one set of mouse event handlers on the editor itself. Okay, within the handlers, the first thing we want to know is whether the mouse was over a node or not, and if yes, which one. We can't rely on e.target alone here, because that only gives us the element directly under the mouse, which may not be the node itself, but one of its children, even though at the moment nodes don't have any children. So we use the method called closest, which starts a search at the element directly under the mouse, going up the hierarchy to find the element that matches this selector. We need an extra state that represents the ID of the node being dragged, which we read from the node's DOM element in the mouse down event handler. And of course, let's make sure that we do put the ID of the node on the node element in the final HTML. As the mouse moves, we update the workflow state to set the X and Y coordinates of that node to follow the mouse. By the way, if you're not used to seeing this way of updating a state, you might want to look up the concept of immutability in React. But in short, we don't mutate a state like this, because this doesn't change the identity of the state. It's still going to be the same workflow object, only with different content. And that would confuse React whether it should re-render or not, because React only performs a very fast identity comparison between the old state and the new state. And if the identities are the same, it might not trigger a re-render of the components. And another cool thing about not mutating the state is that we can store the state before and after every single change, which makes implementing undo and redo very simple. But if you were to mutate the state directly, the implementation of undo and redo would be more complicated. For larger projects, I usually use a library like Next.js to help simplify this, which basically does the same thing behind the scene. Okay, finally, we unset the drag on mouse up, and now we can actually drag the nodes. Great, but we have a couple of problems here. First, the browser keeps trying to select any text it finds as we drag the mouse. That's obviously the default behavior of the browser, so let's prevent the default behavior. Another problem is that the node jumps at the start of the drag, because we set the position of the top left corner of the node to follow the mouse. At the start of the drag, we must store not only the ID of the node, but also where on the node the mouse was, the offset relative to the node itself. We could of course use another user state for that, but notice that these two pieces of information, the ID of the node and the relative point, are set and unset together. They live together, they die together. So it makes a lot more sense to group them together as a single object. On mouse down, we get the bounding box of the node under the mouse and calculate where the mouse is inside that box. And then if we apply this offset during dragging, the nodes don't jump around anymore. And as an indication that the nodes are movable, let's change the cursor when the mouse is over a node. Before we continue, let's do a little cleanup. We are going to do a lot of calculations on positions like this. So first, let's give this data structure a name. It's a two-dimensional vector we call vec, and move the types to a separate file so that they can be used from any other place. And then we create a couple of helper functions in another file for adding and subtracting vectors. And from now on, we can do the position calculations using these functions. Notice that we are spreading the result of the vec sub directly into the node. That just throws both x and y fields in there. In order to connect nodes to each other, we are going to put 4 little circles called ports, one on each side of the nodes. And from these ports, we can drag a line and drop on another port. Let's give the node a larger width and height so that we have more space to work with. Then we position the ports absolutely and give it width, height, and color, and place it according to its class, whether it's at the top, bottom, left, or right. Okay, we can see these ugly ports now. Let's make it look a little better. We draw a blue circle in the middle, followed by mostly transparent white, and then a gray border. And we use border radius to turn it into a circle. Also, we want to indicate to the user that the ports are interactive. So as the mouse goes over it, we change the border color as well as the cursor icon. And of course, we make all these changes smoothly animated. Looks much better now, but it's a little too crowded with all the ports on every node. So to make it a little cleaner, let's only show the ports as the mouse hovers over nodes. Before we implement dragging a line from a port, let's figure out how to draw an edge in the first place. As usual, we start with the data structure and build on top of it. What information do we need to show a link between node A and node B? Well, first of all, we need to know the ID of the nodes being connected. What else? We need to know the ports being connected. It would also be useful to be able to refer to a specific edge in our program, and for that we put an ID there. Later, we might optionally want to put some text on top of the line to describe what the line represents. I'm just going to quickly make the example workflow a little more interesting so that we have something to show. Drawing a line with an arrowhead from one arbitrary location to another is not impossible to do in HTML alone, but it makes much more sense to do it with SVG and embed the SVG inside HTML. After all, these complex arbitrary shapes are precisely what SVG is for. Here we have two options again. We can either make a separate SVG tag for each and every edge, or we can have one container, one SVG tag at the top, and then each edge would become one element, one part inside this SVG. I'm going to go with the latter, and I'll show you why in a moment. To make an edge, we start with a group tag so that everything underneath it can be moved and transformed together. The definition of an SVG path is like a mini program. M stands for move to, and L stands for line to, or draw a line to. So here we are saying move to the position of the first node, and from there draw a line to the position of the second node. This should draw a path connecting the top left corner of the first node to the top left corner of the second. And once we specify the thickness and the color of the line, we should be able to see it. And we do see something here, but there's obviously something wrong with this. It seems to be cropped past a certain point, like the line doesn't go any lower than this area. Here's something to know about how browsers deal with SVGs. You see, we have one SVG element at the top, and the XY positions we set on these paths are relative to the top left corner of that SVG element, which itself happens to be at the top left corner of the page and aligned perfectly with the editor. but we didn't set the width and height of the SVG element itself. And when we don't do that, by default, the browsers assume a size of 300 by 150 pixels, because the standard said so. And anything we draw in that SVG that goes beyond that boundary is invisible. So let's tell the browser not to hide the elements that overflow beyond the boundaries. Okay, now we have a line between the two nodes, and notice that as I move one node, the line updates automatically. That's because moving the node updates the workflow state, which triggers React to re-render the workflow editor, which re-renders the edges, which recalculates the definition of the path based on the new position of the nodes. We want the lines to connect not the top left corner of the nodes, but the ports within those nodes, which means that we need to know the exact position of the ports. And since the ports are in the middle of each side, we must know the exact width and height of each node. And again, we have two options here. One is that we can use a fixed size for the nodes, so that we always know exactly how wide or tall a node is. It's always, let's say, 200 by 100 pixels. But that means that if we change the title to something much longer, the browser won't automatically expand the node to fit the content. Another option is to not use the fixed size and let the browser automatically expand or shrink to fit the content, with some padding probably. But that would mean that at the moment of creating an edge here, the size of the node is unknown, and therefore the exact positions of the ports are unknown. In other words, we can't draw the paths. We don't know where to draw them. We could leverage useLayoutEffect to ask React to let us know when the browser is done with the layout of the page and has decided on the size of all the nodes, so that we can then ask the browser to get us the bounding boxes of the nodes. And from those, we can create the path definitions and set them on the path elements. And by the way, we have to make sure that we do this on every render. So it's certainly possible, but I'm going to go with the first option because I want to have more control over the size than just leaving it to the browser. Even though the size is going to be fixed, I want the size to be different for each node and adjustable by the user. So the browser won't automatically expand to fit the content, but the user can manually resize it. Now when we are drawing an edge, we know exactly where the ports are. And I'm going to write a helper function here that, given a node and a site for the port, will return the absolute position of the port. Okay, it seems to work, but we do have a small problem here. The line is supposed to exit exactly the middle of the port and enter exactly the middle of the other port, but it looks off by a few pixels. Well, let's see. We set the diameter of the port here in the CSS and the offset here. You'd think that the offset should be exactly half of the diameter, right? So that the port ends up exactly half inside the box and half outside the box. Maybe that's the problem. Let's fix this first. Oh, look, it became even worse. Okay, what now? In Chrome DevTools, if you select the node element, it'll tell you that the width is about 143 pixels. But didn't we set the width to 140? The height is also off by like 3 or 4 pixels. If you go to the computed section, the computed tab in the DevTools, you see that it says the width of the content is 140. But then there is a border 1.6 pixels thick on each side. You see what the problem is. The width and the height that we wrote in CSS are applied only to the content of the element, and if the element has a border, then that's an additional few pixels, making the element bigger than we expected. This is of course the default behavior of browsers, which is very inconvenient because it makes these kind of calculations very difficult. Thankfully, we can change this behavior and tell the browser that the given size of any element includes the border. When I say the width is 140 pixels, I mean including the border. And now It's pixel perfect. Remember that we decided to use a single SVG to put all the edges inside? One of the advantages is that we can have some common SVG definitions that are shared among all its children. For example, we can define an arrowhead marker to be placed at the end of each path. It has an ID so that we can refer to it from an edge. It has a size of 8 by 8 units. The position 8, 4 should be exactly at the end of the path being decorated. The marker should rotate to align with the direction of the path. Its thickness should be independent from the thickness of the path it's on. It should be filled using the current stroke color, which is the color of the path. And the actual shape of it, that is the polygon, consists of 3 points connected to each other. The top left corner, center right, and bottom left. And now we can decorate any path using this marker. Before we continue with the drag and drop for creating edges, let's clean up just a little bit. The nodes and the ports should move to another file. And so should the edges. And the workflow editor, along with its own style sheet. And let's take the top level style and variables into their own file. And of course, we import all the files from the places where they are used. Okay, we want to be able to drag the mouse from one port to another to create an edge between two nodes. As always, we start with the data structure. We already have a data structure representing the node being dragged. But let's make it a little more generic. First, it should specify the thing being dragged. Is it a node? Is it an edge? Is it a grid? What is it? If it's a node, it needs a node ID, as well as the position relative to the node. But if it's an edge that's being dragged, what information do we need to draw that edge? Well, we definitely need to know the starting node, and from which side or which port it is started. And we want to know where the edge ends, but it doesn't end on another port or another node. It ends at the current mouse position during dragging. In the mouse down event handler, we must first check if the mouse was over a port. Because remember, in our HTML layout, port is a child of node. So when the mouse is over a port, it's definitely over a node as well. To get the side property of a node, we could check the class name, but we have to check one by one to see if it contains left, right, bottom, or top. A better approach would be to store the side property in the DOM element itself as a custom property, that is anything that starts with data dash, and that makes it much easier to access. While the mouse moves, we can update the position of the edge being dragged. Okay, now we have all the information we need to render the new edge. But there's a problem here. Our edge UI expects a fully formed edge as prop, which includes 2 nodes and 2 ports. But an edge that's being dragged doesn't yet have the other end. Or in other words, the other end is just the current position of the mouse and not a node. We could change the edge type to take that into account, but I really don't want to do that. Instead of messing with the fundamental data structures of our program, which affects everything that is or will be built on top of it, let's see if we can fix it at the UI level. If you think about it, the Edge UI doesn't really need to know about the workflow, the nodes, or the edges at all. All it really needs to know are 2 positions on the grid. So let's pass it exactly just that, and let the parent figure out the differences between a fully formed edge and a partial edge. The Edges UI parent can now take the drag, and if it's of type edge, render a line from the starting node to the current mouse position. Okay, now that we can drag an edge and have it follow the mouse, we gotta actually create the edge inside the workflow state if the drag ends over another port. I'm just going to quickly delete one of the edges in our example workflow and move the nodes a little bit to make it easier to play with. There are a couple more things that we need to do. We must make sure that we don't connect a node back to itself and that we don't recreate an edge that already exists. Okay, it looks really good now, but if you play with it a little bit, you see that it's a little tricky to align the nodes precisely enough for perfectly straight edges. If we make the nodes snap to the grid at, let's say, every 10 pixels, it'll be much easier on the eyes, especially for someone as pixel obsessed as yours truly. The snap function is very simple. It just rounds the number up or down to the given size. But doing this continuously while dragging makes the movement a little janky and stiff. It's better to do it at the very end of the drag. This way, the movement during the drag remains smooth and the node locks into place at the very end. If every node looks the same, the workflow is going to be a little dull and boring. Let's introduce some variety by giving the nodes different shapes. We start with changing our data structure so each node takes one of 4 shapes. Rectangle typically represents a state or process. Diamond usually represents a condition. Pill often marks the start or the end. And ellipse works very well as a junction where multiple connections converge. So far, we got away with drawing the rectangle shape using CSS borders because the CSS border box is a rectangle. To draw arbitrary shapes, however, we have to resort to SVG again. Let's get rid of the CSS border to create a rectangle first. We create the SVG with a rectangle inside that fills the entire parent SVG, and then we style the SVG node itself to fill the entire body of the parent node, positioned absolutely, and also fill the inside with white color and a subtle stroke for the border. Now, you'd think the title of the node should come on top, right? But of course it doesn't work that way. Okay, what is happening here? First, even though in the HTML, the content comes after the SVG and should be shown on top of it, it's actually being shown below the background. That's because, by default, the positioned elements, like the absolutely positioned SVG, are painted after the elements that don't have a manually set position. We could set the Z index of the background to -1, but that pushes it not just behind the node, but behind the entire workflow editor and its background. Here, we must give the node itself a Z index. This creates a separate stacking context for the node and its children. And now, if we set the SVG's Z index to -1, it'll go behind the node instead of going behind the entire workflow editor. There is a lot more to be said about the CSS stacking context, and it occasionally pops up in very confusing ways, and you need to know the basics to be able to solve these situations. I'm just going to give you the links here if you'd like to read more. To create the 4 background shapes, we create 4 components. These components only need to know the width and the height. We've already seen how to draw a rectangle. For diamonds, first we calculate the 4 points and then create a polygon that connects them together. A pill is just a rectangle with extra rounded corners on the y-axis. And to draw an ellipse, we must pass the center point and the radius. Now we create a little object that maps from the node shape, which is a string, to the components that renders that shape. And then in the node, we simply look up the background components and tell React to render that. And finally, let's update our example workflow to show nodes of different shapes. A nice thing about having a map of the shapes like this is that it doesn't have to be hard-coded in this file like this. Instead, it can be passed down from the parent components, essentially allowing users to create custom shapes. We want to be able to drag the grid itself and move it around with everything in it. That shouldn't be so hard. But I've said that before. First, we update our data structure to add another type of thing to drag. Let's call it the grid. And what information do we need to carry throughout the drag? Well, we must know the starting position where the mouse was pressed. Let's start with that. Now, how do we move everything at once? Let's create a new state and call it translation. This represents how far and in which direction the grid has moved. In the mouse down handler, we set the drag type to grid, and as the mouse moves, we update the translation. But what should the value be? First, we need to know how much the mouse has moved. Then the new translation would be the total mouse movement during the drag plus the original translation at the start of the drag. So we must store the starting translation as well. To actually show the translation, the movement of the grid, we can't move the workflow editor div itself. That's our container. We want to be able to embed that inside a larger application with a header and maybe sidebars on each side and with some padding and margin and so on. We want the container to stay a fixed size and not move around. We only want its contents to move. So we must wrap the contents inside a div and move that div. And let's change the cursor to both give an indication that the empty space can be dragged, plus another indication when it is being dragged, for which we set a class name on the workflow editor so that we can control the style from the style sheet. Okay, great. We can now drag the content and move it. I see a couple of issues here. First, the background doesn't move. And of course it doesn't. The background is set on the workflow editor, not on the content div that we actually move around. Well, what happens if we try to set the background on the contents div instead? Would that work? Well, that's just confusing. I mean, the background does move as expected, but it's just this narrow rectangle that doesn't even fill the screen. What's happening here? If we take a look at the dimensions of the contents div in the DevTools, it says 1280 by 150. The 1280 is the width of my screen, and yours might be different. But the height is exactly 150. Why? Remember that everything inside this div, the nodes and the edges, are positioned absolutely. When an element has absolute position, it is taken out of the normal document flow, meaning that its parents don't grow to contain it. So none of these nodes and edges actually make the contents div grow. But there is something in there 150 pixels tall. And that's our SVG tag itself. Remember we put all the edges inside a single SVG element? We made the edges inside the SVG absolutely positioned, but we didn't make the SVG element itself absolutely positioned. And by default, browsers give SVG tags a size of 300 pixels by 150 pixels, because the standard said so. And again, by default, divs grow automatically in width to fit their parent, while they only grow in height to fit their children. And that's why we end up with this narrow rectangle. What if we set its height to 100%? Look, it grew to fit its parent's height completely. Now if we move the content, the grid does move, which is what we wanted, but it's getting cropped on all sides. Well, of course, because the contents div has a specific width and height, and doesn't show its background beyond that. There is no CSS option to set infinite background in all directions, so it's always limited to the boundaries of the element. Alright, we can't have infinite background, but we can use a trick. We can put the background on the workflow editor itself, which doesn't move as we move the content, but then we simulate the movement of the grid by putting a CSS rule that says, draw the background pattern, but shift the pattern as if it were moved this many pixels to the left, right, up or down. And there we go. Now we have an infinite grid to draw on. There's one annoying thing about it though. As we move the contents div, pushing it to the right, the boundaries of the contents are now off the screen. And the browser, trying to be helpful, doesn't want you to miss anything on the page and gives you a scroll bar so you can see what's there. But if you scroll, you are now really off the screen, beyond the boundaries of the workflow editor. and you can see its background ends here. We want to tell the browser that if something goes outside the boundaries of the workflow editor, don't show a scroll bar, just hide it. One more thing, dragging nodes and edges is completely messed up now. And you might notice that it's off exactly by the amount the grid has moved. Obviously, that's because we are not taking the grid translation into account while calculating the positions of the nodes and edges during the drag. For example, in the mouse move handler, when a node is being dragged, we set its position to whatever the mouse position is, but the mouse position that we take from client X and client Y are relative to the top left corner of the window, not relative to the contents div which has been moved. And also, the top left corner of the window and the top left corner of the contents div are not going to overlap if there is a padding or a margin somewhere, or if the website has a heading or some sidebars, or if there is more content on the page than the workflow editor and the page scrolls vertically. So during the drag, we must calculate the mouse position relative to the content div. And to get the mouse position relative to the grid content within the mouse event handlers, we ask the browser to give us the bounding box of the contents div, and then simply subtract that from the current mouse position relative to the window. To avoid confusion in the future, I'm going to update our data structure here to make it clear what the position field of the drag is relative to, and then make sure that we always set and use the mouse position relative to the grid contents. Alright, now everything is back in working order. So far, we've been hard-coding our workflow states with no way to create new nodes from the UI. Let's fix that. We're going to put a vertical toolbar on the left-hand side with a bunch of node templates that we can drag and drop onto the grid to create new nodes. As usual, I'm going to start with the data structure. By the way, if I may digress for a moment, do you remember how to solve a jigsaw puzzle? As a kid, I loved it, and we all learned the trick, right? You start with the corner pieces and work your way in. I think of data structures as the corner pieces of programming. Typically, when I get the data structure right, I can build everything around it, and it all just falls into place. And often when nothing falls into place, and I keep changing things to make them fit but not really making any progress, I know that I must have gotten the data structures wrong. Anyways, back to the toolbar. It's going to take an array of node templates. But what does a single template look like? What information does it need to contain in order to instantiate an actual node? Well, the node itself is a good starting point. Let's just copy-paste that and go through it one by one. Does a template need an ID? Yes, that's actually very helpful to be able to refer to it. But remember that this is the template's ID. Every node that we instantiate from this template is going to receive its own random ID. What about X and Y? A template doesn't need those. We're just going to lay them all out in the toolbar one after another. We do need the size, shape, and title as the default values for the nodes instantiated from this template. Alright, let's create a very simple toolbar that takes an array of templates and renders them one by one, showing only the title for now. And let's render the toolbar in the workflow editor and pass it some example templates. Again, we are gonna hard-code the templates for now. Let's say this is an image processing workflow. So we have a starting node in the shape of a pill, and some rectangle nodes for operations such as cropping, rotating, and blurring images, and perhaps one diamond-shaped condition node that checks the brightness of the image. For the style, we want the toolbar to be absolutely positioned on the left, 100 pixels from the top, and with a z-index higher than the z-index of nodes so that the toolbar comes on top. And for the individual items within the toolbar, let's center the text, change the cursor to indicate that they can be dragged, add an animation when the mouse goes over them, and a little border between them. Okay, it looks good, but to make it better, I want to show an icon on top of each item. When it comes to icons, there are many options. One option is to store the icons as PNG files and show them as images. Another option is to use font icons. I like Font Awesome, for example, and I use it a lot. Even the free version covers pretty much all my needs. But I've been trying something else recently and I really like it, especially for smaller websites. And that's what I want to show you here. It's very low maintenance, lightweight and customizable. We're going to create a new file named SVGs. And when we find an SVG icon that we like, we copy it right here. Or you can just create it yourself in an SVG editor like Inkscape. Although sometimes we need to clean it up a little bit or change a couple of things like the colors. This now becomes part of the source code. So there is nothing to download separately. For small websites where we don't have many icons, I really like this approach. Let's add an icon field of type string to the node template that represents the name of our SVG icon, and then update our example templates to include the icon names. In order to render them in the toolbar, we could import all the SVGs right here in this file and look up the SVG components by name. But the problem is that we'd like this entire workflow editor to be a little more generic, so that it can be used in any application and not just this particular image processing workflow with these particular icons for brightness, crop, and rotation. Which means the rendering of the icon should come from a higher level in the components tree. In other words, the application that is using the workflow editor should provide not only the templates, but also the icons. Because each application will have different templates with a different set of icons. So let's take an icon component as a prop. This icon component is passed from the application to the workflow editor and from there to the toolbar. And now we just need a few more CSS rules to see our toolbar. In fact, there are a few more things like the templates and the workflow state, which must also be passed from the top if we want our workflow editor to be more generic and be used in any context. So let's take those out of the workflow editor file and put them inside client.tsx. This way, we have a much more generic workflow editor without any hard-coded icons or templates, and it can be used in any application. Okay, back to the templates. We want to be able to drag a template and drop it onto the grid, instantiating a new node. The plan is this. The moment the mouse is pressed on a template, we create a new node from that template and move it with the mouse. The first thing we need to know is the ID of the template that was clicked on. We already stored the template ID as a custom data attribute on the DOM element. So in the mouse down handler, we can easily read that and find the template by ID. And we get the position of the node from the current mouse position with a 20 pixel offset, so the mouse is not exactly in the corner, and fill out the rest of the fields from the template. Then we insert the new node into the workflow state and set the drag type to node. The mouse move handler already knows what to do with that drag type. Great, it works. But it does bother me a little bit. Because when we create a new template, it first appears behind the toolbar. I feel like it should be on top instead, right? But changing the z-index of a single node is not going to make it appear on top of the toolbar. Because the parent of the node, which is the grid content, is itself below the toolbar. Which means everything inside the content div is going to appear below the toolbar, no matter what z-index you give it. The only way would be to render the node being dragged outside the contents div. Something like this. And while it's being dragged, we must set its X and Y position relative to the workflow editor rather than relative to the contents div, because it's no longer in the contents div. And we shouldn't insert it into the workflow state until after the mouse button is released. It's all doable, of course, but I think I have a better solution. While a node is being dragged, if the mouse is over the toolbar, just hide the toolbar. And we can even give it a nice animation and with a little delay so that if the user drags it quickly, we don't see a flash. And that's all there is to the templates. Before we move on to the next section, I'm just going to quickly update the example workflow once again, so we have something a little nicer to look at. We want to be able to select a node or an edge, change its title, width, height, and even some custom properties. For example, if the workflow is for an image processing application, then this node that represents rotation needs an angle of rotation as a custom property. Okay, first, what is a selection? A selection here is either a node or an edge. Either way, it must have an ID. And we need a new state to store our current selection, which we set from the mouse down event handler. Now, let's make a sidebar on the right-hand side that takes the selection as well as the workflow state and its setter function for modifying the workflow. For now, let's put a selection ID here so that we have something to show. Then import it from the workflow editor and style it to look very similar to the toolbar on the left-hand side, but a little wider. Now we can select a node and see its ID in the sidebar. We can also select edges, but it's a little bit difficult because of how narrow they are. It's only like 1 or 2 pixels wide, but we gotta come back to that later. What goes in the body of the sidebar? That depends on whether the selection is a node or an edge. Let's do the node first. There are 3 sections: the heading, the properties, and the actions. The first properties we're interested in are the title and the size of the selected node. Let's add some styling for the form too, so that it looks consistent not only with the rest of our application, but also across browsers and operating systems, because the form elements look different on each operating system. And they always have different colors and sizes. And of course, we need more CSS rules for the layout of the sidebar. Sometimes I feel like the CSS rules go on and on endlessly as I try to make what's on the screen look and feel right. This is why it just boggles my mind why Tailwind became so popular. I mean, if it does take a ton of rules to refine the appearance of the page, wouldn't you rather have them written out properly with their full names and separately so you can see the rules in their entirety, instead of shoving them all into HTML classes in shorthand form? It's just one of those things that every time I see it, I think, but why? Okay, as we select nodes, we can see their properties in the sidebar. To make the updating of nodes a little simpler, we're going to write a function here that takes a partial node and updates the selected node. Remember that a partial of a type is the same type, except all of its fields are turned optional. For example, to change the title of the current node, we call updateNode, passing it an object that has nothing except for the new title. And the same goes for the width, the height, and any other property that we'd like to change. Now we can change the title and the size, and it all takes effect immediately. Beautiful. I want some kind of indication on the selected node or edge itself. Perhaps it should be highlighted or a different background color. So let's pass the current selection to the node's UI as well as the edge's UI, and from there we can pass them down to the target node or edge where we add the appropriate class name so that we can target it from CSS to change its style. Let's also change the cursor for edges to make it obvious that they can be interacted with. Okay, we gotta do something about this edge selection problem here. How do you make it easier to select something that's only 1 pixel thick? I mean, I like the fact that it looks very thin. I don't want to make it like 20 pixels thick just so that it can be easily selected. But I want the area that the mouse can interact with to be much thicker than it looks. It's an interesting problem because imagine there are 2 lines on top of one another. One is thin and visible, while the other is thick but invisible. You only see the thin line, but you interact with the thick invisible line. Now, as you can see, it's much easier to select the line. You won't miss it. One more problem that we have here is during the dragging of an edge. Look at the cursor. Sometimes it's the pointer icon and sometimes it's the grab icon, depending on whether in that very moment the mouse was on top of the pointer or on top of empty space, both of which are the wrong icons. First of all, only a fully connected edge is selectable and should have a pointer icon. So let's put a class on the edges that are fully connected and set their cursor exclusively. That takes care of the indecisive cursor icon problem. But also, while we are dragging an edge, we want to show the crosshair icon no matter where the mouse is. So let's set another class name on the workflow editor itself, and in CSS, we show the crosshair cursor on the workflow editor and all of its children while an edge is being dragged, without the possibility of any of the children overriding it. That's what the important flag is for. Okay, let's create the sidebar for the selected edge as well. This is going to be very similar to the node, except that we don't need the width and the height properties. Each edge should optionally have a title as well. This is mostly useful for edges that come out of a condition node. For example, this edge here should have the title yes written on top of it, and this one should have the title no. Its implementation is one of my favorite features of SVG, where you can show a piece of text and tell it to place the text along a path. And we already have a path. That's our edge. Let's give it a unique ID so that we can refer to it. And then using the text and the text path SVG elements, we place the title along our edge. And let's not forget to pass the title as a prop. And just like that, we can show labels along our edges. We do need to change the style a little bit though, to make it smaller and bold when selected with the primary color. Nice. But as usual, there are a couple of edge cases. A few details that only come to light after you use it for a few minutes. First, how come when I select an edge that doesn't already have a title, the title still shows the one from the last selection? That's really weird, isn't it? What's going on? What's going on is that React is getting a little confused here. Let's say we have a selection and the sidebar is being shown. What do you expect React to do once the selection changes? I mean, React has no way of knowing that the sidebar and all the input elements inside it belong to something completely different, and it shouldn't try to reuse the old inputs and states. All it knows is that the props changed, and the value that used to be sent to this text area suddenly became undefined. And because it's undefined, it won't update DOM to reflect the new value, because there is no new value. As far as it knows, that attribute doesn't even need to be tracked anymore. So the DOM doesn't get updated and it stays the way it was, showing the old title. An easy way to test this theory is to give it an empty string if the title is undefined, and you can see it now updates properly. But I don't want to remember to do that for every single field that could possibly be undefined. And also, if the sidebar component itself has some state, then we must remember to update those too every time the selection changes. Instead of these little patches, I want to tell React, look, the selection just changed. Throw everything away and create a whole new sidebar with the freshest state for everything in it. And the way we do that in React is by using the special property key on the sidebar from the parent. React will never reuse the same component and its DOM elements if the key is different from the last render. Alright, looks very good, but there is one more detail to pay attention to. When the edge goes from right to left, the text goes upside down. I did not find a way to tell SVG to flip the text. The solution I found is to use an invisible path, again, whose direction is flipped when the edge goes from right to left, and then have the text follow that invisible path. And since we already have an invisible path for the selection area, let's just reuse that. We also need to adjust a couple of other attributes like the starting offset and the anchor of the text, and that's all there is to it. Oh, and by the way, let's make it so that when a new edge or node is created, it's automatically selected. Okay, beautiful. Deleting an edge is pretty straightforward, but we have to be a little bit careful. Remember that we do not modify the state directly. Instead, we create a new one from the old one. Here we create a new object for edges that shares all the keys and values of the old one except for one that's deleted. After setting the workflow, we must also unselect the deleted edge. So let's add that to the props and pass it down from the workflow editor. And now we can delete edges. Okay, that was pretty easy, but deleting a node is a little bit more complicated because we have to think about what happens to all the edges coming out of or going into the node. Well, we have to delete those too, right? We do that by going over the edges and deleting the ones whose from or to field refers to the node being deleted. And then we set the workflow and unselect the node. Now if I delete this brightness condition, for example, all the connecting edges get deleted as well. Before we move on to adding custom properties, let's look into a little bug that I just noticed. Look what happens as I move the grid and the mouse goes over the toolbar or the sidebar. It tries to select the text. And it happens the other way around too. When I try to select some text in the sidebar, it also drags the grid. One clue to this problem is that nothing like this happens while dragging a node or an edge. So obviously, there is something wrong with the way we handle the mouse events for dragging the grid specifically. If we take a look at the mouse down event handler, we see that the first thing we do before starting the drag of edges and nodes is that we call prevent default on the mouse event, which tells the browser not to do the default thing, which is selecting text as we drag the mouse. But we are not doing that for the grid. So let's do that first. Okay, that did fix the selection problem while dragging the grid, but I can no longer interact with the text area using the mouse. What we're doing here is that we install the mouse down events handler on the workflow editor div. So whenever there's a click inside this div, the handler gets called. And remember, the sidebar is a child of the workflow editor. So a click event that starts there will propagate up and reach the workflow editor as well. So we must make sure that when the mouse button is pressed, the target of the event, that is the element directly under the mouse, is the workflow editor itself, or empty grid, let's say, and not one of its children like the sidebar or the toolbar. To do this comparison, first I'm going to create a reference for the editor. And then in the mouse down event handler, I can compare the target with the editor reference. And now it no longer hijacks the clicks on the sidebar and we can still drag the grid. Except that there is a new bug. You didn't think it would be that simple, did you? There's a not so small dead area on the grid where dragging doesn't work at all. Which means in that area, this condition is failing. There is something there underneath the mouse in this little area, even though it's invisible. Would you like to guess what it is? It's our contents div. We actually talked about this before. Even though the contents div has a lot of children, all the nodes and edges, the children are all absolutely positioned, and so they should not grow the parent's height, except for one child, and that is the one SVG tag that contains all the edges. And by default, browsers give SVG tags a size of 300 by 150 pixels, because the standard said so, which makes its parent, the contents div, grow in height. And because of that, that entire area, although invisible, cannot be dragged because it's not empty. We can fix this problem from CSS. First, we give SVG absolute positioning, so it gets removed from the normal document flow and doesn't grow its parent's height. We also tell the browser to ignore all mouse interactions with this SVG tag which makes it invisible to the mouse. It'll never be the target of a mouse event. But then we restore the mouse interactions for the individual connected edges so that they can be selected and interacted with. And now dragging the grid works perfectly. Is it possible for any application to use our workflow editor as a library? Because each application has different node templates and custom properties for those nodes. For example, in an image processing application, rotation needs a rotation angle, crop needs a size and offset, and blur needs a strength. How can we support such custom properties? How do we allow the top-level application to tell the workflow editor what properties each node must have? And where should the values of those properties be stored? These are all questions about our data structure, which is once again our starting point. The properties are going to be stored on the nodes themselves. From within the workflow editor, we don't know the exact shape of the properties object, because that is decided by the application that is using this library. Here we have two choices. If we want the properties to be typed, then we have to take the type of the properties as a type parameter, in which case every type that uses the node type must also be parameterized all the way up the hierarchy. This approach, although possible, requires more advanced type system programming than I can cover here in this episode. A much easier way would be to skip the types and just say that properties can have any keys and values. We define the description of the properties in the templates from which we instantiate the nodes. But what do we need to know about a property to be able to show a UI for it in the sidebar and update its value in our data structure? Well, first of all, we must know the key for this property that will be used to store it in the properties object. We also need a label to show in the UI, and we must know the type of UI to show for this input. Is it a text, number, checkbox, color, or a list of items to pick from, in which case we need to know the available items too. This type, the way I wrote it here, it works, but let's rewrite it a little bit to make sure that the items field is only available when the properties UI is a list. We need just one more thing. After selecting a node, how would the sidebar know which template the node belongs to so that it can show the available properties based on that template? Let's store the ID of the template on the node itself. And we have to update our code where we create a new node to actually store that template ID. And of course, update the example workflow to include the template ID and maybe some properties. For example, an angle for the rotation. Then we extend our template example to include some properties. The brightness check needs an operator and a value so that we can express something like, if the brightness is greater than this amount, then do this, otherwise do that. Crop needs X, Y, width and height, rotation needs an angle, and blur needs a strength. Oh, and we should probably pass the templates to the sidebar so that we can actually show the UI based on the templates. Alright, all set, let's write the UI. First, we find the node template by its ID, and then go over its properties and render them one by one. We pass the property template, its current value is stored in the node, as well as a callback that will update the node as the property changes. The property component itself is quite straightforward. We switch on the type of UI and render the appropriate input along with its label for each type. We must also make sure that the input always shows the given value from the props and executes the callback with the new value when the user changes the input. But there is one little complication here. Even though the UI of type number does show the right input for entering numbers, the value that it produces is going to be a string. You might think that we could just parse it right here before calling the onChange callback. But that will seriously mess up the UI, because it will prevent the user from entering anything that is not a fully formed number. For example, if the user wanted to enter -90, the moment they type minus, The callback tries to parse that into a number and reset the value of the input. But the minus character is not a valid number and cannot be parsed. This is generally a problem with controlled components in React, and we usually solve this pattern by having an intermediate state for the partial values. Those are the values that may or may not be valid while the user is still typing. But as soon as this intermediate value becomes valid, for example, it can be parsed as a number, then we set the final state. Another solution is to leave it as a string and convert it to number either in post-processing or when we actually use it. In this part, I'd like to show how to build a custom application that uses this workflow as a library. We're going to build a simple but powerful image processing workflow where we can visually set up some image editing operations, drag and drop a bunch of images onto a little gallery we're going to build, then press play and let it run the operations to edit all the images. Our workflow editor component is already very much self-contained and ready to be used in any application. At this point, we could take this component and publish it to NPM as a library, without a server of course, just the front-end React component. We are going to call our app ImageMagick Workflow. Let's create a new file for its component and CSS rules, and move everything from client.tsx to magicworkflow.tsx. We put the workflow editor inside a container below the app header. Now let's make the header by adding a logo and a heading. Let's throw in some CSS rules for the app, the header, and the SVG logo. And put the SVG logo in the svg.tsx, as well as a few other icons that we are going to use in a minute. Okay, very nice. Our web app has two pages. One is the workflow that we see right here, and the other one is the gallery where we display the images and can upload more. We keep track of the current page using a state and change the page using a button in the top right corner of the header. And let's not forget to style the buttons and the layout of the header to show the actions in the top right corner. Let's write the backend for the gallery before we make the UI. First, we have to decide where to store the uploaded images. Let's put them inside a directory called private, right underneath the current working directory, which is our project directory, and we make sure that the private directory is created during server startup if it doesn't already exist. There are three endpoints that we need for the images. The first endpoint returns the list of images, or the file names in the private directory. The second endpoint responds with the binary content of an individual image requested by name. The third and the most interesting endpoint is for uploading images. This is a post request and assumes that the name of the file is included in the request headers and is prefixed with x-, because that's the prefix you have to use for custom non-standard headers. And then the entire body of the request is assumed to be the binary content of the image, which we stream directly into a file in the private directory. And now we are ready to make the UI for the gallery. The function refreshImages fetches the list of images from the server and updates the state. It also stores the response time. We'll get back to that in a minute. Okay, now let's call refreshImages when the component mounts. Another thing you might notice is that the states for both the workflow and the images are stored not inside the workflow editor or the gallery component, but at a higher level. This is a pattern I use very often. I try to keep the states and actions higher in the hierarchy whenever possible. That makes the components underneath it kind of dumb, meaning that they just show whatever you pass to them as props. They don't care if the data was stored somewhere or fetched from the network or hard-coded for a demo. They don't care. It doesn't matter. And when they need to perform an action, such as fetching or uploading images, they ask the parents to do it. This way, not only the parents can easily customize the behavior of the children, but a big chunk of the logic that deals with the state, storage, and network communication ends up in a single place, higher up the hierarchy, where it is easy to find, read, and change. The gallery component is so small, I don't even want to create another file for it. Let's put it right here. It puts the images in a grid, where the source of each image is /image/ the file name, which is already implemented in the backend. But notice the time parameter at the end of the URL. That forces the browser to ignore its cache and fetch the latest image. And by the way, it doesn't have to be the time, and the server doesn't even look at it. All we have to do is to give the browser a URL it has never seen before, to prevent it from showing the image from its cache. To be able to drag and drop images onto the gallery, first we have to tell the browser when a file is being dragged over the page, let me handle it, because the browser's default behavior is to open the file literally in that tab where the file is dropped. And then at the end of the drag, we pass the files to the parents, where a post request is made for each image to send it to the backend. Now let's drop a bunch of images here and see if it works. Oh, it does, but it's in desperate need of some style. Okay, looking much better now. And notice that if we drop a different image with the same name as one already there, it does get updated because of the timestamp trick that we used. Alright, we have our gallery where we can upload images. Before we create an interpreter to run the workflow on these images, let's expand our workflow template so we have a wider range of nodes and properties to work with. For example, a condition for checking the aspect ratio would be nice to have, and so would operations for resizing, brightness and contrast adjustment, letterbox padding, adding watermark, and a sepia effect that imitates the look of old photographs. And let's add their SVG icons too. Now, with an expanded toolbox, let's make a more interesting workflow. For example, start with resizing the images to a maximum of 600 by 600 pixels while preserving the aspect ratio. Then if the brightness is less than 0.4 on a scale of 0 to 1, make it a little brighter. Then add a watermark with the text CodeMic in white in the southeast corner of the image. Then make sure the final image is a square of size 600 by 600 by padding it in black if necessary. And finally, apply the sepia effect to make it look like an old photo. Since we don't yet have a storage for the workflow, I'm just going to grab the final JSON from the DevTools and paste it here as our initial workflow example. Now we add another button to run the workflow on the images. This will make a post request to the server, passing the workflow as JSON in the body of the request, and finally refreshing the images when done. On the server side, first we tell Express that when the contents type is JSON, parse the body as JSON and put it in the request.body, so that we don't have to do it manually ourselves. And then we write an endpoint for running the workflow. But since the code is going to be quite large, let's put it in its own file. Okay, finally, we have the gallery, we have the workflow, everything is in place for us to write the interpreter. We're going to delegate the hard work of image processing to an incredible open source and cross-platform program called ImageMagick, which just turned 35 years old last month. Let me tell you, I dream of creating something that lasts that long. First step, we need a way to execute another program. We could use Node.js's exec file, but that takes a callback and it's a little bit harder to use. But we could use Node.js's promisify function, which converts a function that expects a callback into a function that returns a promise. Then we must check to make sure that ImageMagick is installed on the system and find out under which name, because between version 6 and 7, and depending on the platform, whether it's Windows or Linux or Mac, the command for ImageMagick may be different. Then we write a helper function that runs ImageMagick to completion with the given arguments and returns its output. We want the workflow to be executed on each image one by one. So first we read all the image files from the given directory, and then write a separate function for running the workflow on each individual image. The algorithm is very simple. It's basically just walking over the graph. We have a variable called the current node that is initialized to the starting node. While there is a current node, first perform the action for the current node, whatever it may be, and then follow the first edge out of the current node to find the next node. Repeat until there is no next node. Our starting node is the one whose template ID is a start. For each node, we switch on its template ID to handle each one separately. I'm going to copy paste all the cases for our workflow template, and let's go through them one by one. The simplest one is the start case. Just go to the next node. But finding the next node using the data structure that we have is a little bit difficult, because we'd have to go through all the edges to find out which one starts at the given node. And we have to do that every time. Instead, we could do that once by creating a data structure called the adjacency lists that, given a node ID, it'll give us all the edges coming out of that node. Since the workflow itself doesn't change here, we can do this just once at the top, and it'll make finding the next node as simple as a couple of lines. We'll come back to the conditions in a moment. For the resize operation, we execute ImageMagick on the given image path with the appropriate arguments for resizing, and then save the results back to the same file, overwriting it. That's the entire action for that node, and then we go to the next node. We do the same for crop, rotate, blur, brightness and contrast, padding, watermark, and the sepia effect. They all follow the same pattern. ImageMagick has hundreds of operations with countless options that you may add to the workflow template and the interpreter. The conditions are a little bit more complicated. First, we execute ImageMagick to output the data we are looking for. For example, here we are telling ImageMagick to calculate the width of the image divided by its height. That gives us the aspect ratio of the image in a scale of 0 to 1. Then we take that from the output, which is always a string, and parse it as a number. Now we have the aspect ratio of the image. But remember that we have to compare it to the given value using the given operator. Let's write a little function for that, which takes two numbers and an operator to compare them with and returns a boolean. So now we know if this condition is true or false, and we should find the next node based on that. That is, if the condition is true, find the edge coming out of that node whose title is yes, otherwise find the edge whose title is no. The brightness condition is implemented in the same way. There are just a couple of minor adjustments we need to make here, and that's all there is to it. If we now go ahead and drop a bunch of images here and press run, it runs this entire workflow on every image and refresh the gallery. As you can see, they're all resized to squares of size 600 by 600, conditionally brightened, watermarked, padded in black, and made to look like old photos. We've covered a lot of ground in this episode, but as the saying goes, software, like art, is never truly finished, only abandoned. I'll stop here, but if you'd like to keep building on this, there are plenty of exciting directions you can take. For example, you could start by storing the workflow to local storage, so it persists between sessions instead of being hard-coded. That's probably no more than like 3 lines of code. And from there, you could extend persistence by writing to a JSON file or a SQLite database on the backend. You might also improve the edges so they are drawn with vertical and horizontal segments with breakpoints in between while trying to avoid collision with other nodes and edges. Another cool feature would be undo and redo. Since our workflow uses immutable data structures, keeping a stack of past and future states is pretty straightforward. You could also expand the toolbar and the sidebar to cover more of what ImageMagick has to offer. As I said before, it has hundreds of options and features that you can use to create a much more comprehensive image editing tool. Or you could define new sets of templates and interpreters. For example, swap ImageMagick for FFmpeg to build an interactive movie editing workflow. Or design workflows that orchestrate command line tools for tasks like deployment pipelines. I really enjoyed making this episode, and I hope it's been useful. Thank you for watching, and see you in the next episode.